All right, so we're speaking about osmosis here. And we know that osmosis is the passive movement also called the diffusion of water across a membrane. All right, we know that this is not influenced by the membrane potential. Right, so the movement of water, the osmosis of water is not influenced by the membrane potential. Okay. We also know that water is going to move along its concentration gradient. So that's going to be from high water concentration to low water concentration. Okay? And so basically all of that means is that because we have different solute concentrations on either side of the membrane, we also have different water concentrations. And so we're really looking at the concentration of water when we speak about osmosis. Where's water in the highest concentration and where is it in the lowest concentration? And that's the gradient that our force of osmosis will move along. So let's look at a scenario here. We have two cells. Okay. And let's look at solute concentration here, and then water concentration as well. And we'll look at that inside the cell and outside. Can you see this? Sorry. Okay. All right, and on the second cell, we'll do the same thing. We'll look at the concentrations inside that cell and then outside the cell as well. Okay. Now, we also want to remind ourselves that when we speak about osmosis, the membrane is impermeable to the solute in question. All right, so this membrane that we're speaking about is impermeable to the solute in question. All right, so let's look at our varying concentrations here of solute. All right, so inside the cell here, we have a concentration of 1 mole, whereas outside the cell, we have a solute concentration of 0 moles. And that means that it's pure water, right? So no solutes in the solution outside this cell. When we look at water, the concentration is going to be 100 moles and then 102 moles. And all of that tells us is that the concentration of water is higher outside the cell in this first scenario. Okay. When we look at the second scenario, inside the cell is also 1 mole in terms of our solute concentration, but outside the cell has twice as many particles, right? And we can see that here. So outside of the cell, the solution has twice as many particles. And then if we look at the water concentration, it's going to be higher inside the cell now because the solute concentration is more on the outside of the cell, and then lower in outside the cell. Okay. So in these two scenarios, we're going to have to decipher what direction water will move in as a result of these varying solute concentrations. So because we have more particles in the cell on this side and no particles in the solution here, we have pure water. And again, we're reminding ourselves that the membrane is impermeable to the solute. What we see here is that water is going to want to move from an area where it's in high concentration, which is outside the cell, right, pure water, to where it's in a lower concentration. So here we're looking at the concentration of water, not the solutes. All right, water. So water is moving from high concentration, and we can see that here, to low concentration. All right. Let's look at our second scenario. So which direction do we think water will move here? Again, moving from high water concentration to low water concentration. It's going to be going outside the cell, right? The opposite direction. So we have more water, a higher water concentration inside the cell, simply because we have less solute particles dissolved in here. And you can see that here. And we have a higher solute concentration, but then a lower water concentration outside the cell. And so our direction of osmosis will be in the opposite direction here. Okay. So can we see how, because this membrane is not allowing the particles to equalize themselves, we talked about the concentration gradient, we talked about this chemical driving force. These were the forces that are acting on the particles. And so the particles want to dissociate across this membrane, but they physically cannot. So there's still a force that wants to equalize these solutions, and that'll allow water to move towards the solute. So that'll dilute the solutes. All right, so the important message, is that a question in the back? No? So the important take-home message here is that when the membrane is impermeable to the solutes in question, water moves instead, and it moves along its concentration gradient. So let's just make a note of that. So the driving force here is the concentration gradient of water. Right? That's our driving force for the movement of water, the concentration gradient of water, which is built upon that difference in solute concentration.